In the mid to late 1960s, a revolution got underway that was to change the face of shipping and shape it into what it is today. Containerization was introduced, tankers quadrupled in size, the principle of lateral transfer saw the introduction of ships such as oboes. All ship types saw a dramatic increase in size and service capability, such as ro-ros and pure car carriers, and ships became considerably faster. Missing from this list is the dedicated cruise ship, the chemical tanker, and the gas tanker. All revolutions, however, have one thing in common. They always do not anticipate the final outcome. The big tankers blew up when we started to clean the tanks. That is the Shell tanker Mactra. The big bulk carriers broke in two during loading and discharging. Ships were driven too hard in heavy seas and suffered catastrophic damage. When you put chemicals in containers, they display completely different characteristics than when they're stowed in break bulk. And when you stack containers high up on a ship, even big ones, when the ship rolls, they will fall over. If you take cargo out from the bottom of the ship with cargo on deck, it will capsize. To summarize, there are several types of accident that were never even considered when the fundamental design changes were made. Now, during the time period from when those changes were made until the present day, there have been several very simple changes made to how operations are conducted on a ship. And let me go through them. There is the handheld calculator, the scientific calculator, the programmable calculator, the dedicated navigation calculator, the personal computer, the notebook computer, and then finally, of course, we have the tablet. Let us consider communications. We went from Morse code to radio telex, to SATCOM telex, to email, and now we have broadband internet. Now let's look at the equipment we see on the bridge. The introduction of GPS, the introduction of ARPA, introduction of GMDSS, and the introduction of AIS. And this is a slow revolution. There were no similar accidents with this equipment, but we have had one ship where the cable became disconnected on the GPS, which resulted in a near grounding. We had a case where the ARPA, the full facility, was not utilized and resulted in a collision in the English Channel. And in GMDSS, in the very beginning, when they took the radios on the ship, lo and behold, there were lots and lots of false alerts. Those were resolved by simply fitting a plastic cover over the alert switch. AIS is basically the problem of not updating it with the ship's information. So what have we learned? We've learned a lot of details about dealing with individual problems and mostly workable solutions. But I would argue that we are missing the obvious, and that is we've got to be prepared for the unexpected. ECDIS is now the big revolution. After 200 years of the paper chart, we now have the electronic charge on the bridge. And it's suffering this ongoing culture where we are trying to stipulate how it should be used and etc., rather than listening to the users on board the ships and amending instructions as we go along. Unfortunately, many people are trying to apply old principles to new technology, and the result is a dismal failure. The poor ship's officer is bearing the brunt of this criticism. He's not looking out the window. He's relying too much on instruments. He's not recording the chronometer error. He's using the VHF for collision avoidance. How do we go back? What would the pilot of an A380 do landing his plane in fog if he was told to look out the window, not at his instruments? Do we criticize him? I don't think so. Logic. On ships, when we enter restricted visibility, we say, call an extra lookout. Shouldn't we be calling an extra lookout when he can see something? And perhaps the term call an additional radar observer would be more appropriate. Why has the IMO mandated the fitting of equipment on ships' bridges, and then a string of individuals and groups come along to tell ships officers not to use it? AIS and VHF for collision avoidance are one element, and GPS and accurate position fixing is another. Now we have ECDIS. With such equipment, we find something that I will call language creep. We start off in an official document that says, do not place over-reliance on ECDIS. That then becomes, do not rely on ECDIS, and finally, do not trust ECDIS. If the majority of accidents are attributable to human error, then perhaps it's time we look closely at the instructions or regulations we give ship's masters and officers. This is an ECDIS on a ship in Guangzhou that's set up according to the instructions from a recognized training establishment. And I think, as you can see, you can't see very much. It's over-cluttered. This is a ship leaving Tokyo Bay, with the ECDIS set up as per company instructions to enable them to comply with vetting inspectors' requirements. If you look closely now, hidden amongst all that text are the dangers that this equipment is designed to avoid. This is totally inappropriate use of ECDIS. Another problem that has not been considered is the actual use on board the ship. This is a screenshot from a ship in the Singapore Strait, and you'll see a lot of diagonal squiggly lines, which are telegraph cables. Now, in the daytime mode that we have here, that is okay, but at nighttime, those lines are so bright that it totally destroys the night vision of the ship's officer. A similar location is Lisbon. Also on this screen, you will see this colored shading, this pink color, where one officer has actually marked what I call no-go areas in a very clever way. So something that was very difficult and not recommended by shading in pencil on paper has actually become a very useful tool on ECDIS. But it is possible to clean the screen up. And that's one of my first jobs when I go on board the ship, by removing the cables, etc., and removing some of this information, it makes the whole display a lot clearer. So instead of sharing problems, we should be finding solutions, offering solutions, sharing information, circulating it, so that we can prevent some of these problems on board the ship. We are building up a negative attitude to the new electronics and systems that were designed to remove human error in navigation. Above all, we have created a culture of fear amongst practitioners of navigation to think outside the box. Now, the big revolution is approaching us very, very fast. And those are autonomous or unmanned ships. It's a lot closer than many people believe. And a look at the pie chart of the operating costs of any ship, it will be quite obvious why that is desirable. The people who will drive those ships are the officers, the junior officers who are on board ships now. So if we are not careful and resolve some of the problems and operational issues with this equipment, we will create a new red flag act. That was when a train had to have a man walking in front of it with a red flag to warn people on board on horses to get off and settle their horses so they would not be thrown off.